My name's Andrew Moloney. I am up in Stone in Staffordshire today, meeting with my brother, Paul, because I'm here to learn about 3D printing and Midlands 3D. It's not a space that I understand. We haven't seen each other for
3 years.
Yeah, 3 years for various reasons, which we won't bore you with. But so this is a great opportunity for me to learn about the business and Paul to explain about what's going on and maybe also answer some of the dumb questions I can ask on behalf of all the other people that don't know a lot about this.
So exactly the purpose. I want you to ask those dumb questions, and we'll talk about the whole history. We'll talk about the technologies. I get asked a lot of questions every day from customers who know very little. So we thought it was a great idea for you to actually take over and be that person and ask those questions.
Dumb questions I can do. That's easy for me.
Funnily enough, I know that.
Brilliant. So why don't we start? Why don't you explain kind of some of the history of how Midlands 3D even came to fruition? There we go.
Sure. So 2018, 2017, thereabouts, I thought, I mean, you know me, I've been making stuff for years in the garage, mucking around with radio control cars, all that kind of stuff.
Yeah.
And I decided to have a go at 3D printing. So I think it was 2017, I bought a wooden framed 3D printer secondhand. Printed a couple of things in the garage, thought, wow, this is cool. After a few years, I was, I say a few years, it was probably only 12 months or so. I was putting pictures onto Instagram and just little gimmicky kind of toys and stuff like that, just because it was cool tech.
Yeah.
And a guy messaged me out of the blue and just said, do you think you could make something like this? And it was a little bracket. It was like imagine like a dash cam bracket.
Yeah.
So I said, yeah, sure, I could make that, no problem. And I designed something. I taught myself how to do CAD. And I designed this little bracket and sent him a picture of it. And he went, that's cool. Can you make it do this? Tweaked it a bit. And no problem, printed it. And he was actually local, surprisingly. And he came around, took it and went, this is cool. Do you think you could make 300 of them? And
wow.
I was still there with this wooden printer in the garage and thought, yeah, why not? Yeah, I could do that. Yeah, these printers are only 300 quid a pop. So I did, and that's exactly what I did. I bought another 6 machines. I binned the wooden one. In fact, I think I sold it. Then I had that one producing this batch of 300. I didn't actually realise he works for the OEM of a dash cam manufacturer.
Okay.
And of course, he had resellers. He had people that were wanting the cameras and the brackets to go with them. He was struggling to get stuff from China. We'll come back to that. Yes. So the story goes, this guy started ordering batches of 300, 500 brackets at a time. And I ended up with 15 printers in the garage fairly quickly, within the space of 12, 18 months. And then the word got out, and I started thinking, this is good. It's costing me 15 quid a reel for the plastic, and I'm producing nearly a full batch from 50 quid's worth of material. And it was that was to me the start of spotting that there was actually a growing trend, growing industry. I did a bit of research, and there was a place over in New York who were taking a farm of 100 machines they had, and I thought, this kind of works. There's a growing demand for functional parts, growing capability of the printers to produce them, and I was thinking, this is going to work. And I'll be honest with you, I was in a full-time job, as you know, and doing that at the weekends and evenings.
Side hustle.
A bit of a side hustle, yeah. But it was never supposed to be serious, 100%. I never intended it to become serious. It was more of the demand started to push, and before I knew it, I was producing enough to warrant a unit just around the corner from where we are here on the Whitebridge Estate in Stone. We had a viable business, and Deb, my wife, as you know, she left her full-time job. We took on another guy who's been fundamental to the production, to the success of the business as well. Phil came in and did all the tech while I was doing my daytime job, and
right.
One success kind of led to another, and we started off doing prototyping as a bureau business, and then gradually these orders got bigger and bigger, and we kind of evolved with the business. So we bought more machines, clearly. I mean, at our peak, we had 105, I think it was, FDM machines. So if FDM machine.
FDM?
I knew that was coming. So the FDM machines are anything that uses a reel of filament. These days, they're actually quite common as a hobbyist machine.
So this is what people would have at home generally. So you were really taking what were really domestic size
Yep.
machines
Yeah.
that do what everyone thinks of when they think of 3D printing as the spool and it.
Yeah.
And you
The
print
chances
it
are,
down.
if you've seen a 3D printer or you know somebody who's got a 3D printer at home, it's an FDM machine. So the
Filament.
fused deposition modeling.
Okay. All right.
So that's the filament that's basically drawing the parts
Okay.
in layers.
And it uses heat to melt it fundamentally.
Melting the plastic into a part, and it's building upwards from a flat base.
So that's
So
the orange one, is that?
the orange one and this one here, they're both FDM pieces.
Okay.
I'll talk about the pros and cons of those in a second. There's plenty of sort of benefits to that kind of tech.
Yeah.
And it still has a perfect place. I mean, it has a great place in the market for low cost kind of applications, or low where function is less important, function is more important than form necessarily. Then these are brilliant for that. We do loads and loads of work. Still a core element of our business.
And in the industry, that would be quite common as well. That even making batch manufacture, you'd still use that technology.
Yes and no. So the industry has kind of evolved. So what we've ended up with is a situation where FDM has been around a long time, probably since the 80s. It's been around, but it's been used for prototyping. So it's been used for one-off pieces that might take days to produce. And they're okay when they're done, but you might finish them up and sand them down and whatever. And what's happened is when 3D printing has been prominent in a business, that's what it's been. It's been that technology. The machines have been tens of thousands, if not more, to produce that kind of capability.
Yeah.
And the hobbyist market has just kind of gone in terms of the quality of the machines, the capability of the machines, the power, the material that they can print with. And what you've ended up with is actually very capable, smaller desktop-style machines.
Okay.
Now, we started at the point when they weren't that prominent in industry, in your office, in a designer's office, in an engineer's office, that kind of stuff. If they were there, they could have been gathering dust because they've been around for a long time, and they're the ones that were being used for prototyping. But there was a massive growth in the home hobbyist market, which is where I would have been. And as the machines became more capable, all of a sudden these have started to be used in a production use in industry, where a design office might have one at the end of the office, and they're doing a bit of CAD on the screen, and they're knocking out a prototype in-house rather than going to a bureau. Okay. So we were kind of just at the point, I think, or Midlands 3D started at the point when people were doing that in-house in their design agency or engineer workshop, wherever they were doing it. And they'd gotten to the point of saying, right, we've taken this part, we've tested it, we've used it on our production line, we've changed the little bracket here or a little widget there, and now we need 500. And we've only got one machine in our office. We can't do that anymore. So they've come to people like us as a bureau service. And I say bureau lightly. We were a pure bureau at that time, producing anything and everything for multitudes of industries. When they came to us, they've said, right, we need 500 of this part. We've proven that it's printable. We've designed it so that it's printable. Can you do 500 for us in a sensible lead time? And there we are with 100 machines. And we're doing parallel production. And that was the start of Midlands 3D.
So there's an interesting thing there, isn't there, about, going from 1 to going to 500. Mm-hmm. So clearly there were production methods that existed before 3D, that if you needed 500 parts, you would have had to go and use a different technology. So what were the reasons? And you feel like maybe even what's the break point for people considering 3D printing a batch of products as opposed to using a more, let's call traditional manufacturing method? And what would that look like?
I wouldn't say it's a difficult one to answer necessarily, but there are lots of factors that people are considering. If you take a small organization where potentially cash flow is an issue, if you went to injection molding, you've got tens of thousands of pounds worth of investment required to create the tooling to then start spitting out these plastic parts.
Because you've got to machine a big block of
you have to produce the tooling. Yeah, exactly. Yeah. That block, that tool has to be able to produce, thousands of parts.
Yeah.
And therefore, you need a few things to come into play. One, you need a volume of demand that then makes the maths work out that by the time you've spat out 5,000, 10,000, 100,000 parts, the unit price has come right down.
Yeah.
And also, you need the cash flow in the first place to spend that money on the actual tooling. So you need a fairly rock solid level of demand. You need a rock solid design. You need to be able to, have a business behind you that can actually produce that. What I think the sort of emergence of the hobbyist market has done has meant that people actually have become creative.
Yeah.
They're teaching CAD in schools as a normal thing these days.
Right.
You know, we take students on all the time, and they just sit down in front of the PC and produce stuff that I've got a guy that I've recruited to produce, as and they can just do it because they understand 3D modeling.
It's kind of the new normal. You can do that.
Absolutely, yeah. They're coming into industry and they're starting to produce. They're starting off on screen rather than starting off with a piece of material and hacking away at it.
Yeah.
So the starting point actually is to produce a 3D printable part.
Right.
And that means that the evolution has kind of started off with saying, well, we'll just 3D print what we need when we need it.
Right.
You know, if we don't need to commit to massive amounts of stock, we don't need to this tooling, whatever, well, why can't we just 3D print it and use the machine that's over there gathering dust or potentially being used? And that's really, I think, the evolution of the industry as well, which has meant that, you know, there's lots of change going on. There's and don't get me wrong, you know, 3D printing, absolutely, and additive manufacturing, to use its industry term,
right,
is not a one-size-fits-all solution. You know, every technology has its limitations, is not fit for every kind of application. And, you know, we should never suggest that it's going to be doing everything, because it doesn't, you know, it falls off the cliff in terms of unit cost in comparison to injection molding when you're up to the hundreds of thousands of parts.
Okay. All right.
Inevitably.
So there were two key criteria there that I think I heard you say. I heard you talk about absolute volume, you know, the absolute number you actually want to create, and you know, if it's in the hundreds, then this is probably a good technology to be looking at. And then the other piece was how rock solid the design is, because you're literally going to cast it in, you know, or cut it out of metal.
For traditional manufacturing approaches.
That's what I'm saying, yeah. So
yeah.
If you have a design that you want to customize, or you're not quite sure it's right and you want to iterate, or you wanted each one to be slightly different or whatever, then this is perfect, right?
Or if your market is dictating it. So think about, you know, this is where my kind of background outside of manufacturing, outside of engineering comes in. And, you know, I know the consumer trends right now, the consumer demands are very different to how they used to be 20 years ago. You know, they want personalization, they want hyper personalization,
mass customization,
all those kind of buzz terms that are fantastic. But how does that filter through to your ability to manufacture a part or manufacture a product and stay relevant as their needs are changing all the time? You know, you know, something goes viral on TikTok or goes viral on social media, wherever, and all of a sudden you need that design, you need it out there, you need it live while it's still
right. So it's immediacy.
Yeah.
So I guess the other part then would be where you're manufacturing as well, because I guess, again, anything made of plastic, you immediately think, well, I'm going to make it in the Far East because that's the only way I can do it cost effectively. That changes the economics of all of that as well, presumably.
It absolutely can do. So the bigger picture with additive manufacturing is clearly there's the maths thing around, you know, how much stock are you committing to in wherever it's being manufactured.
Right. Yeah.
There's also that scenario of I can manufacture this closer to my customer.
Yeah.
You know, some of these technologies, if we took HP multi-jet fusion, for example, which is a big technology that we use, if you buy a machine and you've got the material and you're running it correctly, then you can have the same part produced wherever those machines are.
Okay.
So virtual manufacturing networks are absolutely there. There's a thing called the HP Digital Manufacturing Network, which is under HP's heading of certified providers, of which we're one of them, that can produce parts to an acceptable quality, or to actually passing all of their tests to be a quality product using that technology.
Yeah.
You now as a supplier, or sorry, as a customer, could say, okay, I'm going to commit to this. To my global product demands can now be manufactured at all these different manufacturing hubs around the world. I've just cut out a huge amount of supply chain cost in terms of transport, carbon impact, you know, all those kinds of things start to
tankers getting stuck in the Suez Canal with all of your
probably
parts
the best
on
thing
them.
that ever happened to us, I'll be completely honest.
Yeah.
So I mean, as mad as it sounds, we were absolutely influenced. I don't think we've ever spoken about this. We were actually inundated with requests, and genuinely, I'm not exaggerating, inundated with people saying to us, I've got a problem here because I've committed to 20 grand's worth of stock that's an order with my manufacturing site, wherever it was. 9 times out of 10 it was China, but I've committed to stock over there. I've committed to this amount of stock that's on the shelf, and that's now running thin, and everything else is on the water. And aside from the fact that you're thinking, well, hang on a second, you've spent a lot of money on stock you haven't even seen yet. You've just been caught out by the fact that supply chain is actually pretty fragile. And when one card comes out of the house of cards, it all starts to fall down.
Well, and that's the same across so many industries now. So I come from the world of tech, the other end of tech, if you like, IT and technology and cloud and all of that. That's my world. But then for us, when all of that happened, it was all about availability of, actually it was interesting. It was at the two ends of the spectrum. It was chips, it was silicon, and earthquakes in Taiwan and whatever that cause disruptions to that supply chain. But then it was actually the bent tin to put around, the server, those kind of things, which traditionally you'd send out and bend them in, have them made and then ship them to your manufacturing site.
So I think it was a big wake-up call.
Yeah.
It was a wake-up call to manufacturing in general and to consumer products companies, or anywhere that was using distance manufaturing as a whole. I mean, there's lots of things to think about. I mean, I've just realised that we've got a great example on the desk here.
Yeah. You should maybe talk about some of this stuff.
Yeah, so this one, local company in Stone, which is fantastic to be supporting, I have to say.
Right.
Cinetica. They are producing air quality monitoring. Now, these guys had exactly... I'll talk about the great colouring of that. So these are multi-jet fusion printed parts.
Right.
It's the HP process for nylon parts, virtually no geometrical limitations in terms of what they can look like because it's printed within powder, suspended within the powder, so no support.
We should talk some
material.
more about that in a second and talk about HP as well, because obviously
we'll cover off the technologies. So, but this is an example, if we're going back to that supply chain conversation, these guys had a challenge during that scenario where this part normally has electronic components on both sides. Okay,
right.
So it's highly customized to the set of components that they're going to have in this particular batch. Now, what they had ended up with is saying, well, we don't actually know what's going to arrive. It might have 3 holes or mounting holes in this batch. It might have 4 mounting holes. It might be a comparable or a compatible part that's slightly different. So if they'd have committed to this kind of part being mass manufactured and had them all on the shelf, they could have had that scenario of being, there's a bunch of useless parts. Yeah. So
and they would have had to buy them in bulk as well to make it
cost effective. Exactly. So we had the situation whereby the outer cases that are over there, we were mass manufacturing those ones for them, and they were sitting on the shelf because they're universal. These we did based on the batch of parts that came in, and they said, right, okay, I'm going to need to make these few tweaks to the model. Let's fire that over to Midlands 3D, and I need 17 of them printing, please. Yeah, right, sure, no worries. Right. That's the beauty of the technology, because this was customized to that particular batch of parts, and they were with them by the end of the week. So from a point of producing, when we do batches of 200, 300, 400 of these as well. That was just a good example of if they wanted 13 or 14 or 27, that's how many we would manufacture based on the orders that they have. Complete customization, so no tooling, no setup costs. That's the other thing. No constraints around what it is they're going to do. And because they were doing the CAD in-house, Dave, who actually produces these, taught himself CAD during lockdown. I still think it's incredible what he produces. But he's basically absolutely adopted the capabilities of the technology and seen what he can do.
Right.
And still carries on. We're on about a version 120, I think it is, or something of these now. Because he keeps evolving with the demand as well. And as the technology changes, the outer doesn't have to change. His marketing material doesn't have to change because the outside case doesn't change. Yeah. That's just one example, by the way.
You didn't print this in walnut, I'm guessing.
No. So a standard MJF print, we'll talk about technology, but a standard MJF print is like this grey nylon.
Yeah.
We can dye it black, so that is a part that's been dyed black. And then beyond that, you can paint, you can hydro dip, which is what this is.
Okay.
So hydro dipping is applying a transfer to a paint finished part.
Dip it in liquid.
It
floats on the top.
Again, done in Stone as well with a partner of ours. Vital Hydrographics, they produce the to a pattern that you're after. They can even do custom patterns, but these allow you to add a finish to a printed part. Okay. That one is a wooden effect because they needed to hide this air quality monitor just after lockdown, just after all the corona stuff.
Okay.
They needed to put these into public spaces. So being able to A, print the part on demand, B, finish it to the finish that made the sense. And, in a batch, we did some black, some grey, some finished like that. And to us, It's just we print them all together, and then we send them through the different production processes to be able to produce different finishes.
Before we move off talking about this, what strikes me is it's interesting because it's a manufacturing technology, but actually it completely changes, or it can completely change supply chain. So the supply chain guys love it because now you can do this, print on demand anywhere in the world and not have to rely on, the 6 weeks.
I don't want to send them around the world, by the way. I want to do all of it.
Sure. But so the supply chain guy loves it, but also the finance guys are going to love it as well because you don't have lots of stock sitting, that you're not using yet, and you're not committed, or the wastage is very low, and all of those things. So it's interesting how a change in manufacturing technique changes potentially the metrics of how you run your business and how you construct the
it's even
business
bigger
model.
than that. So you can think about your product life cycle and just think about how do I end of life a product without making it completely obsolete for the people that have now got it. So the concept of digital warehousing now comes into play. So digital warehousing is when you take a 3D model, bearing in mind now we're heading into an era of I say heading into, in many industries it's been there a long time, but having a library of digital parts, digital models that you can now hold and now print on demand.
Okay.
So there's plenty of industries now that are starting to say, well, actually, I've got all this warehouse space that's being dedicated to these old spare parts that I don't need to really, I get requested for them once in a blue moon. Why don't I repurpose that space, hold all of the digitally store all of those 3D models and have a partnership with somebody to print on demand.
Okay.
So imagine now we have this in place where the website has a parts catalog capability. We've then populated that parts catalog for you as a customer. We have all of your parts that are on there, and then you're ordering them on demand. We can even drop ship them directly to the customer if they want to. That's an emerging way of working. There's been some great success stories. There's a German garden furniture manufacturer who's doing that. So as they classic example, injection molded parts. Can they do a run of little brackets that break off their chairs? Of course they can't. It's not commercially viable. But they could have it available to 3D print. It's not quite the same as the day that they bought the part, but it's still workable and get the part back up and running again.
That's interesting, isn't it? When you think about sustainability, the ability to lengthen the product or repair the product that you've got rather than build a whole new product.
Right to repair.
In fact, I was going to ask you about right to repair. I mean, whether that actually becomes a solution to be able to do that in a way that's effective.
I think we're a way off. We're a way off. A lot of companies are a way off being able to do that because, again, I'll go back to my point around the 3D printed parts aren't a tick in the box for every single part. You can't produce every single part, not cost effectively anyway. But if we talked about brackets for a chair, hinge pins and stuff like that, things that are wear parts or might break. Part of the service of digital warehousing is onboarding a company into that process. So you actually sit down with them and say, right, here's my inventory of parts. Realistically, somebody who understands design for additive manufacturing can go through that and actually go through and say, right, those parts are a no-go. We can't produce something that's going to be strong enough or rigid enough or whatever, all of the different sort of factors you consider. But then there's always going to be parts that are going to be absolutely, well, we can do them. Yeah. And then there's going to be other parts that you would apply what's called design for additive manufacture principles. So you'd look at it and say, actually, it's printable, but let's put a few more extra strengthening ribs in, or let's put some slightly different features in. It'll still be functional. And it might look a bit different, but it will be a functional part that now is a viable alternative. You work with that supplier to actually create their digital catalog, and then very quickly with very little investment comparably, because you're not producing any inventory at that point.
Yeah, you're not holding any stock.
Yeah, exactly. You're just producing the parts. You're producing the digital records, and we're holding them as a catalog, and you produce them when you need them. It's worth, I think, probably just jumping into the technology of why that works for us.
I was conscious that, because we talked about where it all started with FDM, but that's not really the core of what you're doing now, right? So you're working with HP using their technology. Yeah,
if we just go back to the evolution of Midlands 3D, so we kind of started off in that FDM world, which is, it's hobbyist printing with more capable machines and lots of them. We've got
Okay.
a lot of machines now that we do parallel production with. We're producing with parts or with materials now like nylons and carbon-filled materials, high-temperature materials.
Recycled stuff.
Recycled materials
Yeah,
is the vast majority of our FDM printing is now with recycled materials from a company called Filamentive.
Okay.
And you know, we want to make sure that that technology is used as much as possible for the right applications, because it's cheap as well, to be fair. You know, a little bracket like that is £1 or £2. You know, it's not as cheap as it would be if you produce 10,000 of them with injection molding.
Sure.
But remember the argument of, you know,
And there's cost of money, you know,
100%. Yeah.
if it's sitting on your warehouse shelf.
Yeah. So there's still a place for that technology, and it's still, you know, it's probably 30-40% of our business. No, probably about 30% actually, because it ticks the box for scenarios where a part needs to be relatively cheap, relatively low volume. In that scenario where I can't justify injection molding, it's still a viable solution. So we do customized tubes for inside machines where it's for coin movement. So you put, you know, a coin machine where you stick a coin in and it's
like a water slide for coins.
yeah, exactly. Yeah, I don't know how to describe it. Inside inside a finished part,
Right.
a finished product that looks fantastic on the outside, it absolutely can have 3D printed parts inside. You know, carbon filled materials, PETG, which is a derivative of the kind of plastic you see in drinks bottles.
Okay.
Not so much PLA. PLA is a very basic material that you'd use for sort of decorative applications and very, very quick throwaway kind of prototyping, that kind of stuff, and hobbyist type prints.
Right.
But there's plenty of robust materials that you can use an FDM process for, where the numbers make sense, and by that I mean quantity required and cost that you're prepared to pay for them. Maybe even the life of product. You know, that you want to make sure that there's a sensible level of investment to how long the product is going to last. So that's kind of where the FDM kind of technology sits. What we found as Midlands 3D was evolving, so when we grew from just doing FDM, what we were doing was we were starting to talk to customers who were saying, this is all very well, this FDM stuff, but we need something more industrial spec. We need a nylon, or we need a solid, you know, a solid, strong part, and we need to produce things like this that are far more complex than an FDM print could have produced at scale. There's always this argument, by the way, that I could print that with an FDM process, but it wouldn't last very long. You know, it wouldn't be that great. You know, it wouldn't look as good as that. Cosmetically, it wouldn't work. You know, it wouldn't be a finished product. But anyway, I could prototype it, is the point. The reason why we went with the multi-jet fusion was because HP, so multi-jet fusion is HP's proprietary technology for the production of parts in nylons in the main, using a powder-based process. So when I said FDM is using reels of filament and drawing the part, requires a flat base. It requires a very simple geometry, because if I had something with an overhang in it, like this, for example, where the part goes up and then goes over, I've got to print material underneath it to be able to support that next level up. And then I need to throw away all this support material.
So you often see that, don't you? And hobbyists have to cut away all these various supporting
which is
pieces.
A, it's wasteful.
Sure.
And B, you end up with a slightly degraded surface on that area where the support material is. So you don't really want to be having those kind of limitations and that manual processing as well in volume production. So the reason we went down, one of the reasons why we went down the MJF route is it's a powder-based approach. Okay. So there's a technology called SLS, which has been around a long time. Very similar in as much as it uses a block of powder. This is always a question I get asked a lot. So how do you talk about the powder? Think of an empty box, okay? Empty box of space. Okay. That's the print volume. Okay. Imagine now that box filled with all these parts, any of these parts, in fact, all suspended in space in that powder.
So it could be any combination of hundreds of different parts.
Which goes back to my point around the digital warehousing, around ordering as many as you want. Yeah. I could print every single one of these parts side by side in the same build, and I could have 3 of those, 2 of those, 1 of those. So long as they all fit, then I can print them all in one print run.
Right.
And that means that I can satisfy Joe Bloggs over there who's asked for 1 part, or a company even that's asked for 1 part, alongside that batch of 500 or 5,000 that I'm doing for another customer, which means it's a super efficient process. Right. So that space, that volume, is a block of powder in which there are solid parts.
Okay.
Yeah, got it?
Yeah, you're going to have to cut a diagram in or something.
Yeah, exactly. To show this. So, but imagine now that means in the scenario of FDM where I've got support material underneath here, in this I've got no need for support material because the powder around it is doing that support for me.
Holding it.
And when I lift this out the powder, all the powder falls away, and I'm left with a solid part.
And the machine's doing some magic to turn the powder into solid.
Exactly. So the machine is effectively the multi-jet fusion process basically prints a layer at a time in one swipe. It's a very efficient process. SLS does the same process, but it draws with a laser. So each layer of all of those parts, imagine that box full of parts. If you take a horizontal cut through it, you'd have cut through all of the parts and all of the different bits where you've got to draw the layer. And SLS will go down and it'll do all that drawing. Whereas with the HP process, the print head swipes across from one side to the other, does the entire layer in one swipe.
Right. And so these are all made using that process, and you don't need any of the bits to cut away, and you can.
So the post processing for these is effectively a sandblasting process. So sandblasting in its simplest form.
Yeah.
To remove the powder. So the parts come out of the printing stage, covered in powder. We put them into a machine from a company called Dimension, who do it's like a rotary sandblaster. We hit go. 5 minutes later, they come out looking like that in grey. And from that point forward, we can either, there's your part, that's the finished part that's now ready to be used, or we can dye it black. So remember that's exactly the same thing as this, just been through the dyeing process.
Okay.
And that's been dyed and shot peened to produce a nice satin black finish. This is super popular in the automotive industry.
Okay.
Lots of cars, you won't even realise I've even got those parts on them already. I can't say who, and unfortunately, everything we do is under NDA, as I've told you.
Yeah.
So unfortunately,
but this stuff's fine.
This stuff's fine. Yeah, I can talk about this.
Good.
But everything's under NDA. So we are producing stuff for one company that a household car manufacturer, alongside the guys from Cinetica who are based in Stone, and I might be doing one of these and 5,000 of those, or any combination of thereof, alongside even bits for motorsport, alongside bits for these guys that's a battery pack that we did with some lightweighting involved in it. Right.
So that's super. I guess the other piece. You look at that. And to make that some other way, that's going to be, I don't know how many different components that you would then have to screw together or bolt together or weld together. Whereas now you can just make it as a single thing,
So it's a difficult one for me to answer because, hands up, I'm not an engineer, and hands up, I haven't got, 20 years worth of manufacturing experience. But from what I've been told, that's not even manufacturable in one piece. Looking like complex,
it is. Right?
Yeah, it is.
And it would be multiple materials as well, I would imagine.
Potentially, yeah, because of the level of detail. There's lots of considerations when you're CNCing, when you're injection molding. We don't have any of those. So, I can literally just sit down with the customer and say, what do you need it to do? And this one, the brief was, there's another one of these that's a great big block of plastic. It was reduce the cost, reduce the weight. The weight of this was a big issue. And also add some functions that allow it easier to put together. There's a whole lot of electronics that go into this. We put brass inserts in so that these heated inserts that go into the hole so you can screw things together and take them apart again. Right. We do add some electrical components, all those kinds of things that are possible with an MJF process. That you couldn't necessarily do with FDM, wouldn't quite be right. We could print it, but again, it wouldn't be that pretty, might not be that strong. But with an MJF process, we can do that, and we can do it at scale. So just to finish off the story, we keep talking about the evolution of Midlands 3D, but we went from nearly 100, just over 100 FDM machines. We actually downsized that slightly because the machines started to get faster. Okay. So we could pretty much do the same thing on one of the more modern machines that we were doing on 5 of the previous ones. Oh, wow. Okay. So we've gone through an evolution of removing some of those old machines, putting some new ones in, and then the MJF demand has just gone through the roof. So we're now on 3 5210s, which are HP's. I was going to say that they're the top of the level, but they're not quite. There's already some new ones, but they're efficient manufacturing solutions that the HP designed from the ground up as a manufacturing solution. They'd already spotted that things have moved on from prototyping, and now it's about manufacturing, and they needed a solution in place. So, we're running nearly 10 build units, 3 machines that are printing 24/7. We do 3 batches during the night, 3 batches during the day now. And the machines are just constantly churning out parts, which means if you come along with your order for one part, it generally goes into, again, go back to that volume of space.
Yeah.
If there's a little space in the corner and your print is something like this, there's a fair chance it'll fit somewhere in one of the gaps. And that's what also allows us to be super price competitive.
Yeah.
Pricing is a black art with 3D printing right now. It hasn't quite got the maturity of other production techniques, let's say, and everybody's kind of doing it in a similar way, but not quite the same. But I think that's why you want to focus on manufacturing partnerships as opposed to necessarily just saying, how do I maximize my revenue from this machine? I could make this print like rubbish, but it would be super efficient, but it would print like rubbish because I would orientate it in a way that gets the maximum number into a build.
Right.
That's not going to help the customer. But similarly, if I've got a model whereby not all of my business relies on these, it relies on some of them, some of these, some tiny little widgets that I can use to fill in the gaps, then now I'm running a very efficient print run all the time. And that's why it's better to work with customers and know what they've got coming through the pipeline, working with them and saying, well, actually, that's a candidate for printing. Well, it's only tiny. Yeah, no, but I can print that at the same time for virtually no cost alongside your bigger parts.
Okay.
And the light bulb starts to come on when you're having those kind of conversations.
Yeah, it's almost like a completely different philosophy of thinking about the whole manufacturing cycle. And like I was saying earlier, I think you almost have to think of the price and the cost in the macro rather than just about the specifics of a single part, because of its impact across the supply chain, across your stock holding.
Absolutely. So
all these different aspects.
I keep coming back to this one, but even in the last week, we've just revisited the way we're printing these and actually realized that we can print these with that with a couple of tweaks, that not this version, we can actually print them like that. So we've actually got one bit inside the other. Overall, that's now using a considerably less amount of space than it was. Previous to that, I was relying on having an order where I could fill that space.
Got you.
But now I can price these as a pair, and they can order a set like that.
Perfect. Yeah.
Or I can order, or rather they can order 2 of these where, imagine the other one is turned upside down and we print in pairs.
Yeah.
So they're now using that space that is as efficiently as possible. Now, we do that anyway as part of the nesting process. When you're producing the parts, we nest them into the space and make the most use of the space. But to your point around, if I'm sat down with a customer who is genuinely starting to think about saying, well, we think we could additively manufacture or 3D print more of what we do, then the opportunity for me to sit down and say, well, why not do that, and that? Because I'm thinking about nesting all the time. I'm not thinking about unit cost per part. I'm thinking about that goes really well with that or whatever.
Yeah.
Because it's about efficiency of the print run, not and as a whole, not necessarily just your parts as a customer. You don't have to book in production slots. If you give me an order and it's got a lead time of 3 weeks, I might do the smallest parts of that order that night because I just happen to have a print run available that can put all those bits into it.
Yeah.
And that's my problem. It's not your problem, but I'll price it based on the attractiveness of the parts, if that makes sense.
Right. Okay. So I'm conscious we've probably used a lot of time, and I was going to ask you about, and we've talked actually about lots of different use cases and things you can see, things you can't see, different technologies for different use cases. Mm-hmm. And the kind of state of the art right now, it feels like for this kind of manufacturer is MJF. And just wondering kind of where does it go next? What's the obvious evolution for the industry for kind of the next stage of its growth? Because it sounds like, the whole industry probably, in terms of doing manufacturing, is 10 years old, 15 years old?
Well, I think in its current guise, yes. But the technologies have been around a long time. I think what's happening now is the, like I say, the younger generation are coming through with the education system. They're getting into positions of decision-making power, if you like.
It's going mainstream.
It's going mainstream. It becomes the first point of call when you think about manufacturing.
Yeah.
And I think that's only going to grow
Sure.
It is going to grow. That you see the stats and the growth of the industry is going through the roof. Specific technologies all have their own individual path, because some of them are quite niche. Some of them are clearly have a place, and that's as big as they're going to get.
Right.
Or will own the industry will overtake it. But then there's other ones that are more universal. SLS still has a place. MJF absolutely has a place. MJF tends to be a stronger print, a more durable print than an SLS print.
Right.
Which by the way, is there'd be people who are SLS printers going, "Oh, a lot of rubbish." It's by the by, it swings on ladders and ropes and whatever you want to call it. Yeah.
Okay.
It doesn't really matter. The thing is, powder-based technologies are far more versatile than the FDM style technologies or some of the limitations that you get with other materials. So there is a place for them. Multi-jet fusion from HP. Clearly, I've chose it because I think it's the most durable, the most versatile. It seems to be the one that's being adopted by the biggest manufacturers as well.
Okay.
SLS has been around a long time for prototyping, and it's kind of trying to keep up with the manufacturing kind of perspective, the volume manufacturing. MJF came out from volume manufacturing. It was always intended to be that. So it's faster. The parts tend to be stronger as part of the fully isotropic is the phrase. So it's got strength in all directions.
Okay.
FDM parts don't have that same level of strength. For example, because they're built in layers, there's a natural weakness along the layer line, much like wood does. Yeah. So they have weaknesses in that way. It's better with SLS. It's much better with MJF. Okay. So the parts are more durable, and that means that more industries can adopt it. More applications can use it. More scenarios can be sort of satisfied by using it. So that's why we went that way. In terms of where the industry's going, we're on 3 machines after 2 years. After the first 6 months of our first machine, we'd ordered our second. Yeah. And we're just literally riding a wave of growth. And long may it continue at the minute. We're maxed out. We're already maxed out with the 3 machines we've got. And we've only had our third machine installed just under 6 months ago. So I can only see it growing in popularity. What I think will happen over time is more and more industries, more and more customers will spot that there is an opportunity to sit down with people that really understand the technology. Yeah. And actually maybe just open their eyes a little bit, maybe just suggest actually think about the bigger picture, the supply chain thing. Yeah. Think about that bigger picture, because if you just think unit cost, you're never going to get away from injection molding.
I'm probably never going to get away from sending it out to the Far East and waiting 6 weeks and all of those, and not thinking about, again, the bigger picture of...
100%. But then also taking that other perspective, they're not going to sit down and realize the stuff I was talking about earlier on, where, it's not just about the tech, it's what the tech now enables. The having parts produced in this way means that you can have that mass customization. It's the personalization. There was even a great one a few years back where a marketing agency did a gamification of an online gaming product, and if you reached a particular tier in your gaming, right, and in the post you received a physical product.
Oh, cool!
So imagine that. It's print on demand, sent to the customer. Yeah. And it's entirely customized. And not only that, there's only a handful of them in the world. Yeah. So you've got this sort of real kind of opportunity to jump on the back of stuff like that as well.
It kind of, so not only is it kind of changing the business model of a lot of these manufacturing-based companies, but it's actually enabling some new business models and some new ways of creating new opportunities,
new ways of engaging with customers, new ways of personalizing things. All those kinds of opportunities, I think.
And even in end of life, it's kind of changing the way that potentially end of life is handled. Yeah, extending the length of products usability and all of those kind of things.
Absolutely. I mean, particularly if you looked at the filaments that we use. So sustainability is a huge topic in itself. Yeah. Think about, if you as a company were, your number one thing that you need to fix with additive manufacturing is your sustainability, your carbon footprint, kind of creds. There's lots of reasons why people, will focus on it. But think about the amount of plastics you're using, the types of plastics you're using, the amount of stock you're committing to. How much of that product is genuinely going to end up in a landfill?
Yeah.
Versus I've printed this to A, last a long time, but B, only produced when it needs to be produced. Those are all perspectives that can come into the solution, which is 3D printed,
and with almost no waste as well.
Yeah, so the waste is an interesting one. For sure, there's minimal waste. There's 80% reusability in the powders that are used there. So the powder gets recycled through the process,
right?
And that in itself is fantastic. But when you consider that you're not taking a great big lump of material and CNCing away all of the waste and then putting that to one side, granted that might get recycled, but in plastics it won't necessarily be recycled. In CNC'd plastics, we're producing filament, or Filamentive are producing filament from the waste
of other processes.
Work that out, yeah. So, but I mean, it's fantastic because at least it's not going into landfill, right?
Sure.
But if you think about the manufacturing process of 3D printing alongside the reuse of materials from other manufacturing processes, these things are all starting to come together in a much more harmonious way.
Right.
So yeah, if a company came to us and said, I want to understand, I'm pretty sure we should be doing this, and I have had this question. I'm pretty sure we should be doing this, but I'm not quite sure what we should be doing with it.
Yeah.
Then we can help with that. I've been to a factory and walked around with them and said, what's costing you the most money? And the thing that always costs the most money is tooling, number one.
Sure.
It's downtime, number two.
Yeah.
And that means that, and it's other things that are kind of thorns in their side. Things that they wouldn't recognize are, well, why don't you just create a little bracket that'll help with that scenario, with that process? Why don't you create a little customized jig that will speed the process up?
Yeah.
Oh, that's 3D printing. That's going to cost a fortune. When that costs, £3, and we're doing stuff at the minute where for a customer where we're doing 500 little it's for PCB boards. You understand that? Imagine all the little components bending the legs. They're using tools that are ancient and are not quite fit for purpose, and the people themselves are producing their own versions of it and hacking away at bits of plastic on the desk to make something that works.
Right.
It's like £2 a piece, and we can produce 500 overnight.
Yeah,
really, and that's the kind of stuff that we'll spot walking around the factory.
Yeah,
and suggesting, have you thought about doing it this way? Oh, but the material wouldn't be able to withstand that kind of force.
Okay, so number one is
it would.
Yeah, get someone in who understands the technology and can look at your process.
Yeah, exactly, and and somebody who's realistic as well.
Okay,
don't get me wrong. I'll go back to what I said at the start. There is no one size fits all for 3D printing. This part would be absolutely rubbish if I tried to put it into a functional, vehicle engine bay. Totally useless. This would be overkill for if it was just going to sit on a shelf and look pretty.
Yeah.
But then again, that part is fit for purpose. Touring cars are used. These are used to go underneath the jacks on touring cars, and the whole car sits on 4 of these.
Wow.
And that's a straight MJF print. But they didn't believe that would be possible because they didn't believe in the material, believe in the process, and we had to do it to prove it. But opening those kind of perspectives, if you wanted to accelerate your use of 3D printing, either bring somebody in who's just come out of college and has lots of good fresh ideas, or bring somebody in who's got lots of experience, has seen those kind of things being used, and make sure you don't get led down the line of using the wrong technology for the wrong application, and that's easy done. I've mentioned 2 technologies in FDM and MJF. Through a third with SLS because it's similar. There's 50, 60 different ways of producing materials and 3D printing in general. They might come down to a core set of technologies, but there's loads of variations. Some of them are a sledgehammer to crack a nut, and it's just about finding the right way to achieve something.
Okay.
And very often, large format printing, which we do as well, I've turned people away and said, yes, we could 3D print it, but just use glass fiber. It'll be much quicker, much cheaper, or get it fabricated. A metal shop will produce that in no time, whereas it'll take 2 weeks on my large format printers, and it'll cost you probably 3 times as much as it would have done to have it fabricated. you need that kind of straight talking, realism. Otherwise, you're just going to end up with a sledgehammer to crack a nut.
So get some advice.
Yeah. Basically. Long-winded.
Brilliant. So, Paul, we've talked loads. How do people actually get in contact with you to find out some more about the technology and what you guys do at Midland 3D?
So lots of different channels. Obviously, we're on LinkedIn, heavily visible on LinkedIn. Yeah. Social media on Facebook and on Instagram as well. But by all means, just give us a call. I'm always happy to talk to any customer who wants to bounce an idea around. We do video calls. We do obviously face-to-face meetings. You're welcome to come down and see the showroom, and we'll show you the parts. We've got all these display parts out available to have a look at. I can walk you around, show you the technology. Once you understand the technology as a customer, it's much easier to then go back and visualize how it could be used and remember that, you've had a piece like this and you've done this with it and realized it's super hard and, okay, maybe we can use that.
Brilliant.
So,
cool.
That's the best way.
And the website is?
Midlands3d.com.
There you go.
And telephone number is 01785 594 389.
Brilliant.
All right, good stuff. Thanks.